Good morning, everybody. Here's some review problems for test 3. Problem 1, find the difference quotient. F of x plus h, subtract f of x divided by h. So f of x is a quadratic function, and the first term, f of x plus h, means to replace each x by x plus h. So 3 times the square of x plus h, subtract 2 times x plus h plus 6, and then subtract the function. So you're going to need a parenthesis here because the minus is going to distribute 3x squared minus 2x plus 6, all divided by h. To square the binomial, we need to FOIL x plus h times x plus h. Distribute the minus 2 to get minus 2x minus 2h plus 6. Then distribute the minus sign, minus 3x squared plus 2x minus 6, all divided by h. So now let's hold the 3 and do the FOIL inside of these square brackets. So holding the distributive property on 3, we get x squared. The outer product is 1hx. The inner product is also 1hx. So that's plus 2hx plus h squared. Now to the right, minus 2x plus 2x cancels out, whereas the sum of 0 plus 6 minus 6 is 0. So we're left with minus 2h minus 3x squared, all divided by h. Now distribute the 3x squared plus 6hx plus 3h squared minus 2h minus 3x squared, all divided by h. Now look for like terms to combine. 3x squared minus 3x squared is 0. Now we have a common factor of h. So we can factor out h in the numerator and distribute h times 6x plus 3h minus 2, all divided by h. Now, h in the numerator as a factor divides and cancels h in the denominator. So final answer in simplest form is 6 times x plus 3 times h minus 2. If there's time, we'll come back to number 2, but definitely study how to find the average rate of change of a function. And definitely know the average rate of change is f of b, or the function evaluated at b, subtract the function evaluated at a, divided by b minus a. A is negative 3, and b is negative 2. Number 3, graph the function y equals negative 2 times the cube root of x plus 2 plus 3. The basic function is the cube root function. Y equals positive 1 times the cube root of x. Because the root is 3 odd, the radicand can be any real number, negative, 0, or positive. This function has undergone some transformations. We have coefficient a now is negative, negative 2, multiplies the radical factor, and the function's argument now is x plus 2, and in general, x subtract h. If h is a positive number, we'll have a graph that is horizontally shifted to the right compared to the basic function. And so let's show that if the argument goes from x to x plus 2, and that goes to the general form, x subtract negative 2, means that small h is a negative number because little h is negative. We're going to have a horizontal shift to the left 2 units. All right, let's start talking about the basic function and its graph. We're going to input for x some perfect cubes to calculate their cube root by hand. Negative 8 is a perfect cube, as is negative 1, 0, 1, and positive 8. So the cube root of negative 8 is negative 2. Cube root of negative 1 is negative 1. The cube root of 0 is 0. Cube root of 1 is 1. And the cube root of 8 is 2 because 2 cubed equals 8. So let's graph those points of the basic function. Negative 8, negative 2, negative 1, negative 1, 0, 0, 1, comma 1, and 8, comma 2. So here's a sketch of the basic function. There's an inflection point at the origin. It's not a turning point because a turning point is a local max, like top of a hill, or a local min, like the bottom of a valley. Here, the concavity changes at the origin, and when concavity changes from concave left in quadrant 3 to concave right in quadrant 1, we have an inflection point at the origin. Now we've discussed a being negative, and since a is negative, less than 0, means this basic graph is going to reflect over the x-axis. And the fact that the absolute value of a is the absolute value of negative 2 equals positive 2, whenever it's greater than 1, the y values are increased by a factor of 2, and thus we're going to have vertical stretching. Capital V for vertical stretching. And the constant 3 is generally k. So since k is a positive value, positive 3, that means the basic graph is going to shift vertically, capital V, upward 3 units. So let's locate the new position of the inflection point. It's shifting to the left 2 units and up 3. So left 2 and up 1, 2, 3. This is about here. Now let's get, as it says, 3 points on the graph. And we want to carefully choose the 3 inputs for x, so we can calculate by hand without a calculator. So since the new argument is x plus 2, we're going to pick negative 10 for x, because negative 10 plus 2 is negative 8, which we can compute the cube root of by hand. So we're going to have negative 2 times the cube root of negative 8, because negative 10 plus 2 is negative 8, and then add 3. So that's negative 2 times negative 2 is positive 4, plus 3 is equal to 7. So we have a point at x is negative 10 and y is 7, about here. And we have the new inflection point at negative 2, positive 3. And let's get one more point. Let's pick x is 6, because when you input x is 6 and then you add 2, you get the cube root of 8. So we're going to calculate negative 2 times the cube root of 8 plus 3. So that's negative 2 times positive 2 is negative 4 plus 3 equals a negative 1. So let's go to 6, 1, 2, 3, 4, 5, 6, negative 1. It's about here. So with vertical stretching, the graph will have the following shape. So decreasing on negative infinity. Then we have the inflection point. So now the function, its concavity will be concave right. And it's going to do something like this. So there's a sketch of our transformed function. Domain is all real numbers. The range, also all real numbers. Let's just add a note here. The inflection point is at x is negative 2 after the horizontal shift to the left, and y is positive 3. Number 5, we have a rectangle inscribed in a circle. Let point P be a point on the circle and a vertex of the rectangle. And the radius of the circle is 2. The equation of the circle is x squared plus y squared equals 4. And in case you have to create that, draw a radius from the origin to point P. Draw the altitude perpendicular at 90 degrees. That makes a right angle and a right triangle. And then we have this horizontal leg of length x. X is the length of that leg because x is the coordinate of point P. And the vertical leg has a length of y. Y is the coordinate of point P. And if you read across, y is the coordinate of point P on the y-axis. Now the Pythagorean equation is leg squared plus leg squared equals hypotenuse squared. Let's use C for the hypotenuse. And the hypotenuse is the radius of the circle, which is 2. So x squared plus y squared equals 2 squared, which is 4. So that's how you generate that equation. X squared plus y squared equals 4. Express the area of the rectangle as a function of x. Area of the rectangle is its length times its width. The length of the rectangle is x plus x, because from the origin to the left, that distance is also x. The length is also x. So x plus x is 2x, the length of the rectangle. The width of the rectangle is length y plus another length of y. So the width is y plus y, which is 2x times 2y, or 4 times x times y. Now that's area as a function of x and y, but we want to eliminate y and have only area as a function of x. So we're going to take the equation above and solve it for y. To solve for y, we'll subtract x squared from both sides, so y squared is 4 subtract x squared. We'll take the square root of both sides of the equation. The square root of y squared equals the square root of 4 minus x squared. That gives the absolute value of y. Since y as a coordinate is positive or negative, y is positive as a coordinate in quadrants 1 and 2. Y is negative as a coordinate in quadrants 3 and 4. And this is the square root of 4 minus x squared. So y is positive or negative as a coordinate depending on the quadrant. But as a length, to calculate the area, y is positive. So when we substitute into the area function, we're going to substitute for y the principal square root, square root of 4 minus x squared, now is a product, an expression in terms of x only. So this is a of x, area as a function of x. Area is a square measure, so square units. Express the perimeter p of the rectangle as a function of x. In general, perimeter is the sum of the lengths of the 4 sides. So both lengths added together plus both widths added together. This is 2 times the length plus 2 times the width. The length, again, is 2 times x plus twice the width, and let's put another paren here. The width is twice y, or y plus y. So this simplifies to 4x plus 4y. Now that's perimeter as a function of two variables, but we want perimeter as a function of x only, so we have to substitute for y and eliminate y. So 4 times x plus 4 times, and y is the square root of 4 minus x squared from above. Square root of 4 minus x squared. Perfectly fine. As an answer, you could factor out the 4, but not critical. Number 6, graph the following function. 2 divided by x minus 5 plus 3. State the coordinates of 2 points on the graph. State the equations of the asymptotes or boundary lines. State the domain and state the range. Now, very likely you'll be asked for what is the basic function. The basic function is 1 divided by x. 1 divided by x is the reciprocal function. So positive 1 divided by x. The domain is all real numbers excluding 0. So part C is all reals except for 0. 0 is the restriction. And since x cannot equal 0, and every point on the y-axis has a y-coordinate equal to 0, has a x-coordinate equal to 0, no point of the graph can be on the y-axis. So the first asymptote or boundary line is the y-axis. So we'll indicate that with a dashed line. X cannot equal 0. So all points on the y-axis are excluded. And the equation of that asymptote in part B is x equals 0. And that's the equation of the y-axis asymptote. Now the other asymptote is the x-axis because the fraction 1 divided by x can never equal 0. It's impossible to divide 1 by any number and get equal 0. And 1 divided by x, that's equal to f of x, which is y. So this means that y cannot equal 0, and every point on the x-axis has a y-coordinate of 0. So if y can never equal 0, that means all points on the x-axis are excluded and not on the graph. So we have another asymptote, the x-axis, shown as a dashed line. And the equation of the x-axis asymptote is y equals 0. So in part B, the equation is y equals 0. And now we want to talk about two key points, which are when x is 1 for the basic function, the reciprocal of 1 is 1. So let's state these here as two key points. When x is positive 1, the reciprocal is 1. And that point is in quadrant 1. Let's graph it right here. And given that one point at 1, 1, and knowing the graph of the basic function, as x approaches 0, the reciprocal values get very large, and so the graph approaches the y-axis as an asymptote. And when x gets very large and positive, the reciprocal values approach 0. 1 divided by x goes to 0. So the graph takes on this appearance, getting closer and closer to the x-axis asymptote. And the other key point is when x is -1, the reciprocal of -1 is -1. And that point graphed is in quadrant 3. Now when x goes to -infinity, x gets very large negative. +1 divided by a large negative number is going to 0 but is negative. So the graph remains below the x-axis because the y values or function values remain negative and don't go positive. And since this is an odd function and has origin symmetry, the branch here in quadrant 3 will look like the branch in quadrant 1. And also you can think of it as x approaching 0 from the left, x is getting small and positive, and the reciprocal of small negative values, the reciprocal of small negative values in quadrant 3, as x approaches 0 from the left, the reciprocal values get large negative. So the graph goes off to -infinity and the graph approaches the vertical asymptote. So the two key points at x is -1, y is -1, and x is +1, and y is +1 are centered around the intersection of the asymptotes, and the intersection of the asymptotes is the origin. So now we're going to start shifting and discussing the transformations. One transformation or change is a horizontal shift to the right because the denominator is x in the basic function, but it's x minus 5 in the new function. And so when the argument goes from input x to x subtract +5, means we're going to have a horizontal shift to the right 5 units, including the vertical asymptote. So the vertical asymptote now will be at +5. 1, 2, 3, 4, and 5. So here's the new vertical asymptote at x equals 5. And +3 on the transformed function generally is k. So since k is equal to +3, that means we're going to have a vertical, capital V, shift upward, including the horizontal asymptote. So the x-axis asymptote will go up 3. 1, 2, 3. And so here is the new horizontal asymptote. And the asymptotes intersect. Now the two original key points centered around the intersection of the asymptotes, they're going to translate or move as well. And to find them, we want to let x be 4, makes an easy calculation, right? In the denominator, 4 minus 5 is -1, and pick x equals 6. Those are the two values we want to choose. So let's make a table to the far right over here. Let's say for the new transformed function, we're going to input for x good choices, which are +4, 5, the function is undefined, capital UND, and 6. we want to input 6. 6 will make a nice, easy calculation. 6 minus 5 in the denominator. So careful mental math. If x is 4, 4 minus 5 is -1. Positive 2 divided by -1 is -2 plus 3 is 1. And for x is 6, 6 minus 5 is 1. 2 divided by 1 is 2. 2 plus 3 is 5. So plotting these two new key points at 4, 1 and 6, 5 here. Now notice the vertical distance from those 2 points are a distance 2 vertically from the horizontal asymptote, unlike the original two key points were only a distance of 1 unit from the horizontal asymptote, but because of the vertical stretching, the distance vertical has increased. But the shape is the same with some vertical stretching. So generally, here's the idea: approaching both asymptotes. The graph in blue here. So let's draw both branches approaching the asymptotes, getting closer and closer. Number 7, state the domain and the restrictions. Generally, x can be any real number except for restrictions. And because there's a radical in the denominator which has an index n that's understood to be a 2, which is an even root, a square root and generally even roots must have radicands that are positive or 0 in the set of real numbers. However, we have to exclude any values of x that make the denominator 0 because division by 0 is undefined. So because we have an even root, a square root is an even root, the denominator radicand must be strictly positive so that we have the square root of a positive number and be in the set of real numbers versus the set of imaginary numbers. So whatever value for x we input must give a radicand value that is positive, greater than 0. Now we solve to find the restriction on x. To solve for x, let's add 2 to both sides. And in the next step, because we're going to multiply by -1, you have to do that in a separate step because we're multiplying both sides by a negative number and reversing the inequality symbol. So times -x, reverse the symbol, and -1 times +2. So x must be less than -2. The numerator, -x, can be any real number, negative, 0, positive, but the denominator input for x, so that the square root is a positive number and not equal to 0. This is the domain here, which also can be expressed -infinity, comma to -2 with interval notation. Brief discussion on number 8. Defined in 3 pieces. This is a piecewise defined function. About the first piece, we should know that it's related to the basic function, which is +1 x squared, but with a -1 coefficient. The basic graph, which is a parabola, will be concave down, but only if x is less than 0. So here's just a quick explanation, but you should work out the details. If we input x is a negative value, like -1, the negative of -1 squared is -1. If we input a negative value like -2, we have the negative of -2 squared is -4. So let's graph -1, -1, x is -2, y is -4. And we know it's the left half of a concave down parabola, so we know the shape increasing, 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 but x has to be less than 0, means we're going to have a missing point here, a hole in the graph at the origin. Now when x is 0, y is 4. So that is an isolated point at x is 0, y is 4. The third piece is a linear piece. 3x minus 2 is of the form mx plus b, slope-intercept form, but only if x is greater than 0. So let's continue this table here. Let's input 1. If x is positive 1, 3 times 1 minus 2 is equal to 1. Say x is positive 2, then 3 times 2 minus 2 is 6 minus 2 is 4. Now 3x minus 2 is a linear expression. The graph will be straight like a line, but this is going to be a ray with slope of 2, but its endpoint is a missing point, is another hole in the graph. So let's plot 1, 1, 2, 4, and draw the ray for x is greater than 0. So that looks something like this. Let's draw the ray. Now, right to left, we want to continue the ray, but since b would be -2 if we could evaluate x equals 0, we're going to extend down to y-axis at -2, but again, there's going to be a missing point or a hole in the graph, because for that piece, x has to be greater than 0, cannot equal 0. So there is the graph of this piecewise defined function. Review number 9, which is essentially an algebra problem, except that the new concepts are function notation h of x, which means essentially the function value or the y value. And the other new concept is average rate of change of the function. So make sure to review number 9. Review how to show if a function is an even function, or to show whether or not a function is an odd function. 11 is similar. And 12 is true or false. Okay, let's review number 2. Find the average rate of change of this cubic function, third degree polynomial function, from x equals -3 to x equals -2. Let's look at the function at decimals first. X cubed minus 2x plus 1. So let's look at y equals x cubed minus 2x plus 1. Now you see a tangent line which intersects at one point may have a positive slope or a negative slope or slope of 0 depending on which tangent point you pick. But we want to discuss a secant line that intersects the graph where x equals -3, which is down here at -20. And the second point on the secant is when x equals -2. It's the purple line, and that's at x -2, function value is -3. So those 2 points have an increase in x of 1 unit, because from -3 to -2, that's an increase of 1 in the x direction. Delta x is +1. So between these 2 points, the average rate of change is delta y divided by delta x. And the increase in y from -20 to -3 is +17. And the delta x, or increase in x, is +1. So the average rate of change is going to be +17 over 1, which is also the slope of the secant line, which passes through these 2 points. So now we're going to calculate the average rate of change of this function from x equals -3 to x equals -2. So let's let b be to the -2, which is to the right of a, -3, which is to the left, and compute. The function evaluated for x equals b, -2, is going to be x cubed, which is -2 cubed, minus 2 times -2 plus 1. So all of that is f of b, minus f of a means evaluate the function when x equals a equals -3. So plug in -3 into the function, -3 cubed minus 2 times -3 plus 1. That's all divided by b minus a is -2 subtract -3. And now we'll do the math. So bracket -8 plus 4 plus 1 minus -27 plus 6 plus 1, all divided by -2 plus 3 is 1. That's the increase in x. Delta x is +1. So now this is -8 plus 4 plus 1 is -4 plus 1 is -3, minus -27 plus 6 is -21 plus 1 is -20. And there you see is the difference of the function values, or y values. This is equal to -3 plus 20, which is +17. That's the increase in y between the 2 points divided by the increase in x plus 1. This is delta y divided by delta x, which is the slope m of the secant line through the 2 points. Number 10, determine algebraically whether the given function is an even function, an odd function, or neither. Recall that a function is even if by definition, f of negative x equals f of x. A function is an odd function if f of negative x equals the opposite of f of x. So to see if function capital F is even, we're going to evaluate f of negative x and replace every x by negative x cube root of 2 times negative x squared plus 1. And simplify this. This is the cube root of negative x squared is the same as x squared plus 1. Well, this radical cube root of 2x squared plus 1, that's the same as the original function. This is capital F of x. It's the same as f of negative x. So the graph is going to have y-axis symmetry, and we can declare or state that this is an even function. So in conclusion, this function is an even function. Now, if you had done the other test for an odd function, and you wanted to try to show that f of negative x was equal to the opposite of f of x, if you would have got a negative sign in front of the radical, then you would know the function is an odd function, but that did not happen. This is not an odd function. Number 11, given function g, show algebraically whether the function is even, an odd function, or neither. So let's first do the test for an even function. We're going to input for x, negative x. In the numerator, we have the opposite of negative x cubed divided by positive 3 times negative x squared minus 9. And simplify. So the numerator is the negative of negative x cubed. Then you have the negative of a negative, which is going to become x cubed. The denominator is 3 times x squared minus 9. So this equals x cubed divided by 3x squared minus 9. Now, when you compare this last fraction to the original expression, the original fraction, they're different by a negative sign. Right? This is the opposite of g of x. G of x has a negative sign in the numerator. Therefore, we have g of negative x has been shown to be the opposite of g of x, and thus, by definition, function capital G is an odd function. So in conclusion, therefore, function g has been shown to satisfy the definition of an odd function is an odd function. These last two are short answer, True or false, the squaring function, f of x equals 1x squared, is an even function, and its graph has y-axis symmetry, is true. The reason is if we do show algebraically what happens when you input negative x for x and simplify, we get x squared, which is f of x, the original function. So we've shown that f of negative x is the same as f of x, and this satisfies the definition of an even function, and the graph will have y-axis symmetry. As we know, the graph is a concave of parabola. The left branch has or is symmetrical with respect to the y-axis, and the graph is concave up. So, conclusion, thus we have shown algebraically the definition of an even function has been satisfied, and function f is an even function. True or false, the cubing function, y equals x cubed, is an odd function, and its graph has origin symmetry. Well, let's show that the definition is satisfied. The definition is if we input negative x into the cubing function and simplify, negative x cubed, since 3 is odd, is going to be a negative of x cubed. And x cubed is equal to f of x. So if we substitute f of x for x cubed, this does show that the definition of an odd function is satisfied, meaning f of negative x is the opposite of f of x. Therefore, this cubing function is an odd function. And its graph has origin symmetry. So just to review quickly what that means visually. The cubing function, well, if we input 0, 0 cubed is 0. If we input 1, 1 cubed is 1. If we input 2, 2 cubed is 8. So let's make 8 about here. So if we input x is positive 2, f of 2 is positive 8. And since the cubing function is an odd function, f of negative 2, when you cube negative 2, you get negative 8, which is the opposite of positive 8. So if we reflect that point 2 comma 8 over the x-axis and over the y-axis, we get its image over the origin. So going down, this would be negative 1, 2, 3, 4, 5, 6, 7, negative 8. And we'll get a point on the graph at x is negative 2. Function value is negative 8. Also, if we reflect over both axes, the point 1 comma 1, x is positive 1 becomes x is negative 1, and y positive 1 becomes y negative 1. So that's this point here in quadrant 3. And here's a sketch of the graph of the cubing function, which is increasing left to right on its domain, which is all real numbers. And the graph has origin symmetry. So this point in quadrant 3, input the opposite of x, -2, you get the opposite of f of x, which is -8, is on the graph.